Hello guys, welcome to the video. In this section we're going to work on camera. It's going to be a pretty simple setup that will allow us to move around the field. I want to show you my prototype so you can see how it's going to work. So this is the game window, and first of all we can rotate around, so we can rotate around to see the field. We can zoom in if we want and rotate around that point. We can also move around like that with the AWSD. You can also move with the arrow keys. And if you want, you can hold the wheel button and also move around the field like that. This point over here is just for reference, it's not going to be there. And this is how camera is going to work. You can move around, you can fly around the field. And also if you try to fly too far from the level itself, it's not going to let you. It's going to stop you and you're going to just sort of move back to the center of the map. As you can see, I'm trying to fly away and it doesn't work. It pushes me to the center of the map. All right, so that's what we're going to do in this section. It's going to be a custom script that we're going to make together. I'm not going to use Cinemachine. I only want to use built-in functionality. If you have a little bit of experience, you might know what is a Cinemachine and how to work with it. But Cinemachine can be a bit of an overkill for this setup, so I'm not going to use that. Also, I checked, there are plenty tutorials on YouTube on how to set up Cinemachine, so I thought it's better if I show you just how to make a custom script for this. All right, we're going to start by making a script. Camera controller. Now let's take the camera and let's put the script on. And I just want to say that for this, we're going to use old input system again, because new input system is kind of an overkill for this project. It will take us 20 to 30 minutes only to set up the new input system, and we can just do the same with the old input system. Usually new input system is used when you have multiple input devices, for example, keyboard and gamepad. But I imagine this game will be playable only with the mouse itself, so we don't really need to switch between devices. And if that's the case, then we can simply use old input system. Don't let it scare you. It's just called old input system because it was developed first, but to really think of it, it's more like simple input system and advanced input system. That's how I would call them, honestly. So yeah, let's begin with the input first. I want to show you how it's going to work. We're going to make public float vertical input. Then we're going to make public float horizontal input. Then we're going to make a method, private void handle movement. And just for now, we're going to make v input equals to input get axis row vertical. And axis are WASD keys or arrow keys. And let's type h input equals to input get axis row horizontal. Just that. Now we're going to call this method in the update. And we're going to go and see what values we have in the inspector when we press in the buttons. Okay, let's go back. Let's go to play mode. And if you want input to work, you need to select game window. Now we can press the buttons. And you can see when I'm pressing to the right, we have 1, left -1, up 1, down -1. And that is what we need. We're going to use this input to adjust movement of the camera. All right? Very well. You can try it yourself. Now let's stop the play mode and let's go to the script. And we can remove these now because we know how it's working. As well, we can remove start method. And over here, I'm going to type float to make it work as a local variable. Now, we also need a variable vector3 target position equals to transform position. We're going to adjust target position according to the input we have. Then we're going to take transform position of the camera and smoothly change it from a current position to target position. That's how it's going to work. We only need to know the speed of the movement. So we're going to do serialize field, private float, movement speed. Let's make it 120 by default. Also, we're going to need two variables in the future. We're going to do private float smooth time. Let's make it 0.1f by default. And let's make private vector 3 movement velocity. And I'm going to make it equals to vector 3.0. Very nice. Now let's try to move camera to the left or right. We're going to do that by checking if we have input on a horizontal axis. We're going to do if each input is bigger than 0, then we're trying to move to the right. So we're going to do target position plus equals transform right multiplied by movement speed, and we're going to multiply it by time.delta time because we want to make it frame rate independent. And we're using transform right because we want to move to the right or left. For the movement to the left, we're going to do this. If each input is less than 0, then target position minus equals transform right multiplied by movement speed multiplied by time.delta time. This is what we need. Now let's try to apply the movement according to the target position we calculated with the input. That can be done. Type in transform position equals to, and over here we're going to use something new. We did not use it before. It's going to be vector 3 smooth dump. This will make movement of the camera smooth and nice. We only need to type here the current vector we have, which is going to be transform position of the camera. Then we want to give it a target position we want to have, and that is the position we calculated with the input. So we're going to type here target position. Then it requires a velocity, and it also should be referenced. So we're going to type ref movement velocity. That is the variable we created before. Ref allows method not only to use variable, but to adjust it as well. And that's what we need to have to make this method work. And lastly, we need to type here smooth time. All right, this is good. It's going to make it work. Let's try this. We're going to save it, and we're going to go back to Unity. Then over here, we simply can go to play mode, and we can use A and D or arrow keys to move the camera. And you can see I can move camera to the left or right, because we adjust in position according to the transform right over here. It is done with the movement speed, and not to make it too fast, we make it frame rate independent with the time.delta time. And the movement itself is smooth like we have over here, just because we're using smooth dump. That is probably the perfect solution for this one. Now let's try to add vertical movement. I'm gonna exit play mode. And over here, we need to do a bit of a trick to make it work nicely. Before I show you what we need to do, let's try to do transform up. Because, like, if you think of it, you just want to move camera up or down, right? So that's what's going to happen with a vertical input. Let's try it. If vector input is bigger than 0, then target position plus equals transform up multiplied by movement speed multiplied by time.delta time. If vertical input is less than 0, then we can duplicate this and replace plus with a minus, like so. Let's save this and let's see what we have. So now we have movement of the camera to the left or right, and also we can move up and down. And this could work. If you like it this way, you could use it this way. But for me, I want to do things a bit differently. I want camera to fly across the plane like so when we press W. Not just to move up, but I want it to move along the plane. That's my idea of it. We could use transform forward instead of up. But again, it's not going to give us exactly the result we want. Let's try. Let's save it. Sorry. Let's save it and let's go back. Now we can move to the left or right, and also we can make camera fly forward or backwards. This also could be used if you can rotate the camera, why not? But again, I wanted to move like along the plane, like so. So you know how to make this movement, and later on you can adjust the camera if you like it this way. However, we're gonna do something different here. We want to make camera move forward, but we wanted to ignore the Y. We want it to move only along the X and Z axis. Basically, we need a flat forward. That's what we need. We can achieve it by using project on plane method. Let's try this. Let's type over here vector 3 flat forward equals to vector 3 project on plane transform forward and then vector 3 dot up. Now let me try to explain what it does over here. Basically it's like we get in the forward if we like, wait, how do I explain this? It's this one is not easy. We kind of get in forward according to the up over here. It's like, hey, give me a forward of this plane over here, of this vector. Just another example, it's like asking this method to tell you what is your forward if this is your up. You're sort of giving it up vector over here, and you're asking what is my forward direction would be if this is my up direction. This is what it does basically. Yeah, so now it will make it move along the plane. Let's go over here and type, wait a second, it's better to make it normalized over here. Let's do normalized. Then we can go here and just do flat forward. Flat forward. Alrighty, this is good. Now let's save it and let's go back to the Unity. Let's go to the play mode. And now if you try to move around, you can see camera moves to the left or right, but when you push forward, it's going to move like that along the plane. So now we can fly across the level and you can see different things. We also need to add rotation. That's going to be later. As of now, this is good enough. That's just what we need to do. Yeah, we have the movement of the camera. Again, once we have rotation, if you want to change it, you can. You can replace it with a transform forward, for example. But for me, I think this is a perfect way to do that. Also, I just want to say that this is probably the best way to write this one. I spent not 1 hour on making it work just like I wanted to work. This was not easy, and I'm very proud of the result we have over here. So yeah, that's gonna be it for this video, and I'll see you in the next one.